So dear friends, in the last lecture, we have learned very important topic, that is method of variation of parameter. We start the next topic, that is Cauchy homogeneous linear differential equation, which is also important topic for you. And we will solve this problem by method of variation of parameter. Okay. So Cauchy homogeneous linear differential equation. Cauchy homogeneous homogeneous linear differential equation. Linear differential equation. So what is the Cauchy homogeneous linear differential equation? So an equation of the form of the form, write down the equation, x raised to n d raised to n y by dx raised to n, and plus a1 x raised to n minus 1 d raised to n minus 1 y by dx raised to n minus 1, and plus a2 x raised to n minus 2 n2 d raised to n minus 2 y by dx raised to n minus 2, and plus so on, plus a n minus 1 x dy by dx plus a n y, and this is equal to x. Okay, name this equation number star. So we name this equation number star is called Cauchy homogeneous linear differential equation. Linear differential equation of order of order n, or simply you can show the simply you can say that this is the Cauchy equation. Okay, where a1 a2 a3 up to an are are constants, and the right hand side x is the only function of x, is the function of x. Okay, is the function of x. See here. So an equation of the form x raised to n d raised to n y by dx raised to n, and plus a1 x raised to n minus 1 d raised to n minus 1 y by dx raised to n minus 1, and so on up to a n minus 1 x into dy by dx plus a n y equal to x. So this equation is known as what? Cauchy homogeneous linear differential equation. Okay, why this so? Because in this equation, see here, if there are nth order derivatives, so here x raised to n, the polynomial of order must be n. If here n minus 1th order derivative, then here x raised to n minus 1, polynomial of order n minus 1, and so on. मतलब कि जिस ऑर्डर का डेरिवेटिव रहेगा वो उस ऑर्डर का एक्स पॉलिनोमियल यहाँ पे मल्टीप्लाई होगा. ठीक है, मतलब हर एक टर्म क्या है कि डिग्री कितनी होनी चाहिए? सेम होना चाहिए. सो दैट्स व्हाई इट इज नोन एज कॉची होमोजेनियस लीनियर डिफरेंशियल इक्वेशन. ओके, so what are the methods to solve the Cauchy homogeneous linear differential equation? So there are methods how to solve this type of differential equation. So Method of substitution. Method of substitution. Substitution. Okay. So the equation star can be solved by putting x equal to e raised to z. Okay. So the star equation star can be solved can be solved by putting x equal to e raised to z, or this can also be written as z equal to log of x. Okay, and we write and we write x dy by dx equal to dy and x square d square y by dx square equal to d minus 1 y and x q dq y by dx q equal to d minus 1 d minus 2 y and so on and so on. Okay, if there are next order term, that is x raised to 4 into d raised to 4y by dx raised to 4, then what happen here? The next step, d minus 1 d minus 2 into d minus 3y. Okay, and similarly this step can be repeated again and again. If there is higher order, then this step repeated like that. Okay, so and so on. Okay, therefore the equation 1 reduced to equation 1 means what? Equation number star. Therefore the equation star can be reduced to, or you can say the equation star reduced to linear differential equation with constant coefficient with constant coefficient. Okay, with constant coefficients. Okay, now let us see how to solve this type of problem. So for more understanding, let us take one example. So example, see here, uh, this is the homogeneous linear differential equation known as what? Cauchy homogeneous linear differential equation. Okay, so how to solve this type of equation? By substituting x equal to e raised to z. Okay, if you substituting e raised to z, then this equation can be reduced to like this: x dy by dx equal to dy, and second term, second order derivative can be reduced to x square d square y by dx square equal to d minus 1 y and so on. Okay, then this equation number star and reduced to the linear differential equation with constant coefficient. You know very well how to solve the linear differential equation with constant coefficient by using different types of method we have seen. Okay, so we will solve this equation by using, either you can use variation of parameter or other next 5 methods. Okay, so let us see example based on this. We write example number 1. Solve solve x square d square y by dx square plus 4x 4x dy by dx plus 2y equal to e raised to x equal to e raised to x. We have to solve this equation. Okay. Solution. So before solving this, we first copy the given differential equation as it is. So given is this Cauchy homogeneous linear differential equation? Is this Cauchy homogeneous linear differential equation?
Yeah, so it is a Cauchy homogeneous linear
Yes,
equation.
it is Cauchy homogeneous equation. Why is this so? Because there are second order derivative and the polynomial of order 2 is present over here. Okay. And this is the first order derivative and polynomial of order 1 is present over here. Okay. And the y is here constant term or y last term. Okay. And the right hand side is e raised to x. So this is the Cauchy homogeneous linear differential equation. Okay. If this is not a Cauchy homogeneous equation, then what have to do? First we have to make this the Cauchy, then we have to solve. Okay. We will see that type of problem in the next type. Okay. So let us solve this. First we copy the given differential equation. So write down given differential equation, Cauchy homogeneous linear differential equation. Given Cauchy homogeneous linear differential equation. Linear differential equation. What is that? That is x square d square y by dx square and plus 4x dy by dx and plus 2y, and this is equal to e raised to x. Okay. How to solve this Cauchy homogeneous linear differential equation? By putting x equal to e raised to z. So here we put x equal to e raised to z. Okay. And write x dy by dx. Okay. Equal to what? Equal to dy and x square d square y by dx square equal to d minus 1 y. Okay. Just write down here. So therefore equation star, name this equation number star. Therefore equation star reduced to, therefore the equation star reduced to linear differential equation, linear differential equation with constant coefficient, with constant coefficient. Okay. Just substitute this. So d square sorry, x square d square y by dx square. Instead of this we putting this one. So write down d minus 1 y and plus 4 as it is a, we are not putting the value of 4. So x dy by dx is what? Dy. So dy. Okay. And plus 2y as it is, 2y as it is. Okay. Now here, come to here. So x equal to e raised to z. X equal to what? We putting here x equal to e raised to z. So this can be also be written as z equal to what? Z equal to log of x. Z equal to log of x. ऐसा लिख सकते हैं. Here
Yes.
x we putting here x equal to e raised to z. So or you can write z equal to log of x. So write down e raised to, but x is what? E raised to z. E raised to z. Okay, x is e raised to z. Now just simplify this here. Uh, Here we can observe that y is common in each term. So take y as a common. Take y as a common. So we will go for next page first. So what is that here? d d d minus 1 y and plus 4 dy and plus 2y, and this equal to what? E raised to z. Okay, now we will have y as a common in each term, so we will take y as a common. So this become, write down d minus 1 plus 4d and plus 2. Okay, now y as a common from each term, and write down this equal to e raised to z. Okay, now just simplify this. So multiply this, so this become d square minus d and plus 4d and plus 2. Okay, and y, and this equal to what? E raised to z. Okay, now again simplify. This is what? D square and plus 4d minus d, that is 3d, and plus 2 and into y equal to what? E raised to z. Okay, now see here, this type of problem we already solved in the last lecture. Have I solved this? Yes or no?
Yes, sir.
Yeah.
For auxiliary equation, we put here d square plus 3d and plus 2 equal to what? 0. Okay, now find the roots of this. What are the roots? What are the roots? Can you find? So d,
Minus 1, minus 2.
okay, uh,
Just the-
d plus 2d and plus d and plus 2 equal to 0. Okay, so just find out the roots. This is d square, so I am taking d as a common, so d plus 2. Okay, and plus 1, so d plus 2 equal to 0. So we write d plus 1 bracket and d plus 2, and this is equal to 0, another bracket. So from this we will have d plus 1 equal to 0 or d plus 2 equal to 0. So from this you will have minus 1 and minus 2 roots. Yes or no? Yes or no?
Yes, sir.
Yes,
Yes.
Ah,
sir.
therefore the complementary function is given by, therefore the complementary function is given by, what is the complementary function? Yc equal to, since roots are distinct,
C1 e raised to minus
हाँ, roots are distinct and non-repeated, so c1 e raised to minus
C1 e
x.
raised to minus x
x नहीं, see here, यहाँ पे x will not be there. Why is this so? Because we converted entire x into functions of z. Okay, so हाँ, this is what? This is your complementary function in the form of z only. So c1 e raised to minus z, you have to write like this, and plus c2 into e raised to minus 2z. Okay, the complementary function is given by yc equal to c1 e raised to minus z plus c2 e raised to minus 2z. Name this equation number 1. Okay, now our job is what? To find out the particular integral. To find particular integral pi. Okay, here y1, your y1 is what? E raised to minus z, and y2 equal to e raised to minus 2z. Okay, so find out the function. So w of z, W of z, or you can just write down W. Okay, so W equal to y1, y2, y1 dash, y2 dash. Okay, and this equal to y1 is e raised to minus z, and y2 is e raised to minus 2z. Okay, and y1 dash minus e raised to z, y2 dash minus 2 e raised to minus 2z. Correct? So I'm taking derivative of this. So just find out the determinant. So just cross multiply. Just wait. ये एक मिनट. हाँ, इसका यहाँ पे माइनस आएगा.
ऊपर
Yes.
प्लस रहेगा.
e raised
Yes,
to
yes. हाँ. Now just cross multiply. So
माइनस
this
टू
become e raised to j. हाँ हाँ. Minus minus plus. So e raised to minus z into e raised to minus 2z. So base is same. Base is same. The power will be added. Okay. 2 e raised to minus 3z. Okay. And plus यहाँ पे base is same. E raised to minus 3z. 2z 2 times, negative 2 times and 1 times. So this become negative of 1 times e raised to minus 3z, and which is not equal to 0. Correct? It is correct?
Yeah,
So
sir.
this is your determinant, which is not equal to 0. Therefore, you can say that y1 and y2 are two linearly independent solution. Therefore, y1 and y2 are two linearly independent solution. Solution किसका? Of 1. Of equation star. ठीक है. इक्वेशन स्टार मीन्स कहाँ गया आपका? ए वाला इक्वेशन, जो इक्वेशन ये है ना, इसका सोल्यूशन हो गया. ये कौन सा इक्वेशन है? इसको आप इक्वेशन नंबर स्टार दे दो. पहले वाले को दिया था क्या स्टार? इसको स्टार दिया था, तो इसको आप 1 दे दो.
डबल स्टार दे दो.
हाँ, इसको 1. हाँ, डबल स्टार. यस, करेक्ट.
सर 1 नीचे है.
इसको डबल
1 नीचे है ना.
हाँ, इसको डबल स्टार दे दो. ओके, इक्वेशन नंबर डबल स्टार. ठीक है. नाउ वी फाइंड u and v. So for particular integral we will determine u and v. Let us move to the next page. So we find u. Your u is negative of y2x by w dx. Okay, but here सभी किस में चल रहे हैं? z में चल रहे हैं, तो हम यहाँ पे z लिखेंगे. ये फार्मूला है आपका. ठीक है, dx. तो आप मैं फार्मूला लिखूंगा u इक्वल टू नेगेटिव y2. योर y2 इज व्हाट? y2 इज e रेज टू माइनस 2z. y2 इज e रेज टू माइनस 2z, और x आपका क्या है? x आपका e रेज टू z है. ओके, एंड डिवाइड बाय, अभी मैंने फंक्शन क्या फाइंड किया? नेगेटिव e रेज टू माइनस 3z. नेगेटिव e रेज टू माइनस 3z एंड dz. ओके, सिंप्लीफाई करो, माइनस माइनस प्लस. सो ये ऊपर गया e रेज टू माइनस 2z e रेज टू 3z into e raised to z and dz. Okay, so this can be written as integration of e raised to z. Okay, वाले दिस टर्म यहाँ से 2 है, ये यहाँ से कम हो गया. e raised to z, then e raised to z and dz. Okay, solve this. So what I have to do? We putting here put
e raised to z equal to t.
Yes, e raised to z equal to t. So this implies that e raised to z dz equal to dt. Okay, some substitute कर दो. So this equal become e raised to t and dt, and I have this equal to e raised to t. Okay, integrating this e raised to t. Now replace the value of z. So e raised to z. Sorry, replace the value of t. So this is e raised to z. Okay, correct. So we replacing the value of t
Sir.
e raised to z. Now find v. Also we find v. V is equal to integration of y1x by w and dx. Okay, but your equation in terms of z. So we write the equation in terms of z. Y1, how much y1 found? E raised to minus z. Y1 is e raised to minus z, and x, your x is what? E raised to z by what? By what? Negative of e raised to minus 3z w and dz. Okay, just simplify this. So after simplification, minus 9 here, a denominator comes in the numerator, so e raised to minus z into e raised to 3z plus हो गया, and e raised to z and dz. Okay, just simplify this equal to negative of integration, base is same, the power will be added, that is 2z e raised to z. Okay, and dz. Correct. Now what? Now just take common. We breaking this, so we write this as it is, like this. So we breaking exponential function, so e raised to z into e raised to z into e raised to z and dz. Okay, like this. Now we putting a z equal to, put e raised to z equal to t. So this become e raised to z dz equal to dt. Just substitute over here. Therefore, v equal to negative integration of e raised to z is t, and e raised to z dz is what? dt. So e raised to z is t, and this is what? dt. Just integrate by using generalized integration by parts. So negative sign I'm taking outside. This is u, this is b. U integration of v e raised to t, and derivative of u1 integration of v1, that is e raised to t. Okay, and this equal to, just resubstitute the value, negative e raised t is what? E raised to z, and e, but t is what? E raised to z minus e raised to z. Okay, e raised to z, just multiply minus and inside the bracket, so this become e raised to z into e raised to z. This is minus and this will plus, e raised to z. Correct. So now what? Therefore yp, is what? Yp equal to, your formula for yp is u y1 plus v y2. Okay, so u y1, so I'm substituting over here, u is what? Your u is e raised to z, e raised to z, and y1, your y1, uh, y1 is what? Just tell me y1.
E raised to minus z.
uh, e raised to minus z is y1. hmm? E
Yes,
raised
sir.
to minus z, yes,
Yes, sir.
y1, and plus v, your v is this, negative e raised to z, negative, negative e raised to z, then e raised to z, and plus e raised to z, or y2, your y2 is e raised to minus 2z,
Yes, sir.
e raised to minus
Yes,
2
sir.
z. Okay, just simplify this, इधर ही इसको सॉल्व कर लेंगे. So e raised to z, e raised to minus z, मल्टीप्लाई करो माइनस, सो यहाँ से एक पावर कट जाएगा, सो माइनस e raised to z, e raised to z, okay, then plus e raised to z into e raised to माइनस 2z. ये तो गया घर पे, ठीक है, गया ना. एक मिनट, यहाँ से माइनस साइन आएगा तो दिस इज
माइनस आएगा सर.
माइनस माइनस माइनस, ये यहाँ पे माइनस आएगा, ठीक है, आएगा ना, ये गया यहाँ से. तो यहाँ पे क्या बचा आपको, दिस इक्वल टू e raised to z into e raised to minus 2z. This is the yp. Okay, now name this equation number 2. Therefore the complete solution is given by therefore the complete solution is given by y equal to yc plus yp. Now add them. So yc, we found yc is c1 e raised to z, just c1 e raised to minus z, and plus c2 e raised to how much, minus 2z, yes,
Yes.
and plus we found particular integral. What is the particular integral? E raised to z, e raised to minus 2z, okay, e raised to z into e raised to minus 2z. okay, now अभी आपको रिप्लेस करना है, ठीक है. now replacing the value of z, therefore y equal to c, e raised to z को क्या लिख सकते हैं हम, x raised to minus 1, ठीक है, एंड प्लस c2 e raised to z को क्या लिख सकते हैं हम, x raised to minus 2. ओके, इतने पार्ट को मैंने क्या पुट किया था, e raised to z को क्या पुट किया था, x पुट किया था ना. सो प्लस e raised to z को मैं क्या लिखूंगा, e raised to z को x लिखूंगा, e raised to z को x लिखूंगा, और e raised to z को x लिखूंगा तो क्या हो जाएगा, x का माइनस 2 हो जाएगा. इसको मैं और अगर अच्छे से लिखूंगा तो c बाय एक्स प्लस c2 बाय एक्स स्क्वायर एंड प्लस e raised to x by x square. okay, this is here complete solution of given Cauchy homogeneous linear differential equation. Now understood this?
Yes, sir.